Okay, starting with the activity 2.3, moving on to the first question, we have f of x is equal to e to the power of x square into cos x. Okay, so mind you that cos x is also in the power. Okay, so let's say what is this differentiation? F of x is equal to e to the power of x square into cos x. So this is a composite function. So let's say what is f dash of x? F dash of x is equal to, it is in the form e to the power something, right? So anything to the power of e will be always e to the power something. So what is that something? That is x square into cos x. So now we have to differentiate what is in the power. So that is this is product rule, right? Multiplied by the differentiation of x square is 2x cos x as it is plus x square as it is into cos x is minus sin x. Okay, so this is nothing but e to the power x square cos x into 2x cos x minus x square sin x. So do we have this option? Yes, so option 4 is the answer. Next one, limit x tends to 0 plus, so we are moving from the right hand side. Okay, for the function sin x divided by square root of x, so we have sin x divided by root x. This is limit x tends to 0 plus. Okay, so this is nothing but, we know the form sin x by x tends to 0, so this will be equal to 1. So we, instead of x we have root x. So what I'll do is limit x tends to 0 plus, I'll just write sin x by x as it is. So if I have to convert the root x to x, I have to multiply by root x. So since I've already multiplied by root x, I have to also divide by root x, right? So if I cancel this again, I'll retrieve this back to the original form. Okay, so now this value is 1. So what happens to square root of x? So instead of x, if I substitute 0, the whole value will be equal to 0. Third option is right. Moving on, uh, f of x is equal to x mod x. So this is the function given, x mod x. So if we recall, mod x is nothing but, we can have three different values for this. It will be x if x is greater than 0, it will be 0 if x is equal to 0, and if it is minus x if x is less than 0. Okay, this will be the function values for mod x. So what will be mod x into x? So now f of x, we can write this as, we have x into x, that is x square if x is greater than 0, it will be 0 if x is equal to 0, and if it is minus x square if x is less than 0. Okay, for this, what will be the differentiation of this? So the differentiation is f dash of x will be equal to, x square will be 2x for x greater than 0, will be 0 if x is equal to 0, and minus 2x for x less than 0, right? So we can combine this x is equal to 0 for the upper value, right? So that will be given by the first option, right? uh, f dash of x is equal to x is if x is greater than or equal to 0, or minus 2x if x is less than 0. Next question, we have f of x and they have asked us to find out this value. Okay, so now let's substitute the value here. So that will be limit x tends to 1 of f of x is nothing but square root of 9 minus x square minus f of 1. F of 1 is, if we substitute 1 here, 9 minus 1 square, so that is root 8. So we have root 8 divided by x minus 1. What happens if I directly substitute 1? So I'll have root 8 minus root 8, that is 0, and 1 minus 1, that is also equal to 0. It is indeterminate form. If we have this form, directly apply LH rule. If we apply LH rule, what we'll have? We'll have limit x tends to 1, differentiation of the numerator. that is f dash of x. F dash of x is given by, this is in the form x to the power n, that is nx to the power n minus 1. Here n is what? N is 1 by 2. In place of x we have this 9 minus x square. Okay, so here we'll have 1 by 2 into x to the power, x is nothing but 9 minus x square to the power 1 by 2 minus 1, that is minus 1 by 2, and into multiplication of this differentiation, that is nothing but minus 2x. Okay, this is f dash of x. Also, if we simplify this, we'll have minus 2x divided by 2 into square root of 9 minus x square. 2 and 2 will be cancelled. What's remaining is minus x divided by square root of 9 minus x square. We can substitute this for the numerator, minus x divided by square root of 9 minus x square. Okay, whole divided by differentiation of x minus 1 is 1. Here minus, this is a constant, right? So we'll have 0 over here. So if we substitute 1 now, what will happen? We'll have minus 1 divided by square root of 9 minus 1 square. So that is nothing but minus 1 by square root of 8. So this is the answer. Next one, consider the function log base x 5. Okay, so we have to find the differentiation of this. So that is nothing but f dash of x is given by log base x 5. So we can use the change of we can change the base of this equation into natural log of 5 divided by natural log of x. So now if we differentiate, we'll have, this is in the form 1 by something, right? So we have a variable 1 by x. So here in place of x we have log. So log 5 is constant, we can take it outside, and now we can differentiate 1 by x. What is differentiation of 1 by x? That is nothing but minus 1 by something square. So here I'll repeat that, minus 1 divided by this something is nothing but log, right? Log x whole square. So what is into multiplication of what is log x differentiation? Log x differentiation is nothing but 1 by x. Okay, now if we simplify this, I'll have minus log 5 divided by x log square x. Okay, so now I can write this as minus log x, log 5 by log x into log e. So mind you that natural log of e is nothing but 1. So in place of 1 I am writing this divided by log x into 1 by x. So here what will this be turning out to be? That is minus log base x 5 into log base x e whole divided by x. Second option is the answer. Moving on. Okay, so which of the following one can apply L'Hospital's rule to evaluate the limits? Okay, now let's substitute these values. We'll have infinity by infinity. Okay, so let's apply L'Hospital's rule for this. So differentiation of numerator is 1, so differentiation of denominator is 1 plus cos x. So now if we apply infinity, what will happen? Cos infinity is again infinity, right? So we cannot determine this function value. We cannot write this as infinity. Why? Because the function value will be in between 1 and 2. Okay, in between 1 and 2 we don't know which value of this exists, right? So we cannot determine this by applying L'Hospital's rule. For the second one, let's say if we apply 0, sine 0 is 0 and cos 0 is 1, 1 minus 1 is 0. If we apply L'Hospital's rule, we'll have 2 sin x cos x in the numerator divided by minus sin 2x into 2. So that is nothing but 2 will be cancelled. Now we have sin x cos x divided by 2 sin x cos x. All of this is cancelled. What is remaining is minus 1 by 2. Yes, we can find the value by L'Hospital's rule. Moving on, if we apply infinity, again we'll have infinity by infinity form. Let's try to differentiate the numerator. We'll have 1 by x whole divided by 3x square at the denominator. Now if we apply infinity, we'll have numerator will be turning out to be 0 and the denominator is infinity. So again we'll have 0 by infinity. Again this is an indeterminate form. Okay, now again if we instead of applying directly, let's simplify this. That is 1 by x whole divided by 3x square. That is what we have. If we simplify this, we can send this to here. We'll have 1 divided by 3x cube. Now if we apply infinity for this, apply the limits, we'll have 1 by infinity, so that is nothing but 0. Yes, we can also evaluate this. Okay, so last one, if we apply 0 directly, we'll have 1 by 0 is infinity. But this is an unbounded function. So this is not indeterminate, it isn't just an unbounded function. These two options are right. Next one, we have f of x plus y is f of x into f of y, given that f of 9 is equal to 6, f dash of 0 is equal to 4, and f dash of 9 we have to find out. Let's say we use 9 plus 0 is equal to, what is x is 9, that is f of 9 into f of 0. Okay, so what is 9 plus 0? Again it is 9. So we'll have f of 9, I'll take this to the LHS, I'll have f of 9 into f of 0 is equal to 0. Now if I take f of 9 as common, I'll have 1 minus f of 0 is equal to 0. Now 1 minus f of 0 is equal to 0 and f of 0 is equal to 1. Okay, so now if I have to find out the value of f dash of 9, if I use the first principles, I'll have limit h tends to 0 of f of 9 plus h minus f of 9 whole divided by h. So this is nothing but, okay, for this again I'll apply this given condition. Okay, so now what I'll have, limit h tends to 0 of f of 9 into f of h minus f of 9 whole divided by h. I'll take f of 9 outside, f of 9 multiplied by limit h tends to 0. I'll just write this in another form. I'll write f of 0 plus h minus, I'll have 1 here, right? So instead of 1 I'll write f of 0 because 1 is equal to f of 0 divided by h. So now this whole value is nothing but f dash of 0, right? So this is equal to f of 9 into f dash of 0. F of 9 is given by 6 and f dash of 0 is given by 4. Therefore f dash of 9 is equal to 6, 4 times is 24. So this is the answer. Moving on, f and g be two distinct function from R to R. Which of the following statements are true? They have given us f into g is differentiable, then both f and g are differentiable. We know that if the reverse is true, right, but the forward is not true, so this option is wrong. assume that if g of x is not equal to 0 for all x belongs to R. If f by g is differentiable, then both f and g are differentiable. Again, the reverse is true. If f and g are differentiable, then f by g is differentiable, but the reverse will not be true. This is true, but the reverse is not true. Okay, so f is an even differentiable function, then f dash is an odd function. If so let's say what is even function. Even function is nothing but if f of x, if let's say if I have f of minus x will be equal to f of x, so this is even. So if f of minus x is equal to minus f of x, then it is odd. Okay. Okay, so now let's consider f of x as even, right? So f of x is even. I have to find out what is the differentiation of this even function, right? So we know that f of x is nothing but f of minus x. So I can substitute this d by dx is equal to f of minus x. So if I differentiate this, I'll get firstly I'll get f dash of minus x into differentiation of minus x is minus 1, so that is nothing but minus f dash of minus x. So here I'll have f dash of x, right? So this is nothing but the definition of odd function, right? So if f of x is odd, let's say, okay, so we are interested to find out d by dx of f of x. So we know that f of x is nothing but minus f of minus x, right? So we'll have minus as it is, f of minus x differentiation is f dash of minus x, and differentiation of minus x is minus 1, so minus and minus will be cancelled. So what's remaining here is f dash of minus x. Here differentiation of f of x is f dash of x, so this is nothing but a even function. So this both options are